Okay. Okay, children, good afternoon, all of you. Let us continue our class. So, the morning session, we have discussed the relations, type of relations, okay, equivalence relation. Now, I will continue with the function, okay, functions, some examples from functions. And after that, I will discuss inverse trigonometry functions, okay. Some of the students have demanded to teach the inverse trigonometry functions. So first I will discuss some problems from the chapter, from the area functions. After that, I will be moving on to the inverse trigonometric functions. Clear? So this is the question. One question from the functions actually. Prove that the function f from n to n defined by f of x equal to x square plus x plus 1 is 1, but not on 2. I'm not going to explain what is 1 function. Okay, na? Okay. Okay, children. I think some problem was there. Okay, some network issue. No, it is okay. I don't know whether you followed what I have started. Okay. So I have started this example. The function f from n to n defined by f of x equal x square plus x plus 1 is 1 1 but on 2. Prove that this function is 1 1 but not on 2. So for that, to prove a function is 1 1, the method all of you may be knowing. Let f of x1 equal f of x2, where x1 and x2 belong to the domain that is n. So f of x1 stands for x1 square plus x1 plus 1, and x2, f of x2 stands for x2 square plus x2 plus 1. Isn't it? Then 1 is common for both sides. So 1 can be cancelled from each side. Then shift everything in the left side, you will get x1 square minus x2 square plus x1 minus x2 equal to 0. Okay? So x1 square minus x2 square plus x1 minus x2 equals 0. Okay. After cancelling 1 from each side, you will get like this. Now this implies x1 plus x2 into x1 minus x2. Factorize x1 plus x2 into x1 minus x2 plus x1 minus x2 equal to 0. Okay. So that means x1 minus x2 is common. So x1 minus x2, you take it outside. So in bracket, you will get x1 plus x2 plus 1. x1 minus x2 is common factor. Take it outside. So you will get x1 minus x2 into x1 plus x2 plus 1 equal to 0. Now this implies we know the product of two terms equals 0. That indicates that either the first term, first factor, x1 minus x2 equals 0, or x1 plus x2 plus 1 equal to 0. Either the first factor is 0 or second factor is 0. Now from here, what you'll get? x1 plus x2 plus 1. Can it be 0? Remember, x1, x2 are natural numbers. x1, x2 are natural numbers only. So never, it is not possible that x1. So only possibility is what? x1 minus x2 must be 0. Okay, children. Again, some problem is there. Okay, a lot of technical problems may come sometimes, na? Some internet problem and some connectivity, some other issues are there. Okay, I don't know whether you could have followed the previous talking. So this is my question actually. We have started the question. F of x equal to x square plus x plus 1. To verify it is 1, 1 or on 2. Okay. So we are going to prove it is 1, 1. So we have taken x1 equal x2. So f of x1 equal f of x2. Then after simplification, at last we have received the stage x1 equal to x2. Okay. So that means this function is 1, 1. This function is 1, 1. Okay. Let me check the video whether it is going on. Okay. No problem. Any chat? Nothing is there in the chat. Okay. So 1, 1 is over. Okay. 1, 1 is over. Now we have to prove, yeah, we have to verify whether it is on to or not. Okay. Actually, it is given the question itself that prove that it is not on to. Okay. Prove that it is not on to. So how we can easily prove that it is not on to? The function is f of x equal to x square plus x plus 1. Isn't it? And function is a function from natural numbers to natural numbers, n to n. Okay, n to n. So we have to prove that, yeah, show that it is not onto. Not onto means there may be some element in the codomain which don't have a pre-image here. Okay. So what we do? Let us take 1. Let's see whether any pre-image is there for 1. Okay. If there is a pre-image, is it possible that f of x equal to 1? That is, we have to check actually. Okay. Is there any element x such that f of x equal to 1? If f of x equal 1, what you will get? Then x square plus x plus 1 must be equal to 1. If there is a pre-image for 1, then definitely f of x must be equal to 1. For some x, that means x square plus x plus 1 must be equal to 1. So that implies x square plus x equal to 0. X square plus x equal to 0. And this is possible only if x into x plus 1 equal to 0. Isn't it? X into x plus 1 equal to 0. And that means what? That means x equal to either 0 or negative 1. But 0 is not a natural number. Negative 1 is also not a natural number. So very clearly 1 has no pre-image in the domain actually. Okay. 1 has no pre-image. There is no x satisfying f of x equal to 1. Okay. 0 or minus 1, both values are not in the domain of this given function. Okay. Both are not natural numbers. That means 1 has no pre-image. 1 has no pre-image means it is not an onto function. What is meant by onto function? You know, every element must have a pre-image in the domain. Then it is called onto. So one example is enough to show that it is not onto. Okay. You take any one particular element which don't have a pre-image. Okay. This is actually a very simple 1 mark question actually. If set A has 5 elements and set B has 6 elements, then the number of 1, 1 and 1, 2 mappings from A to B is, what is the answer? Okay, I think you may be knowing the answer. This a similar question, yeah, this may be the same question was in the term 1 examination, isn't it? Okay. So set A contains 5 elements and set B contains 6 elements. So the question is, how many 1, 1 and 1, 2 mappings are there from A to B? So what is the answer? The answer is 0, because it is not possible. Okay. If A and B are two finite sets, okay, if A and B are two finite sets, and if there is a 1, 1 and 1, 2 mapping function from A to B, then both the set must have the same number of elements. Then that is the only possibility. Okay. So we know the arrow diagram. Suppose we have two sets A and B, and set A contains 3 elements, and set B contains 2 elements. Can you make any 1, 1 function from A to B? No. It is not possible actually. No? 1, 1 function and 1, 1 and 1, 2 function. It is not possible actually. So the number of 1, 1 and 2, 1, 2 function may be 0 only. Okay. We can draw like this, but you can find a free element here. Then it may not be a function. To make it a function, we have to map this element somewhere. If I map here, then it is not a 1, 1 like that. Okay. So if two finite sets are there, and if there is a 1, 1 and 1, 2 function, a bijective function, both the set must have the same number of elements. So the answer is 0 actually. Okay. Now suppose another question. Suppose a set A has 3 elements and set B has 2 elements. How many functions can be made from A to B? In the morning, we have discussed relations, okay? How many relations are possible from A to B? There was a question in the first term examination, okay? How many relations are possible from A to B? I think everybody knows A cross B contains 6 elements, and any relation is a subset of A cross B, means 2 power 6 relations are there. Okay. Now the next question, suppose how many functions are there from A to B? How many functions are there from A to B? Total number of functions. Total number of functions. So the formula is, if this has some n elements and this has some m elements, number of functions from A to B. Please note this formula, that's all. Okay. Number of functions from A to B is equal to n raised to m. Okay. Number of functions from A to B is equal to n raised to m. Then next question. How many 1, 1 functions are there? How many 1, 1 functions are there? So in this case, you know, we cannot make any 1, 1 function when set A has more elements than set B. You know? So when m is greater than n, the number of 1, 1 functions will be 0 only. Okay. Suppose this second set contains more elements. Okay. N is more than, greater than or equal to m. The second set contains more elements than the first set. So the question is, how many 1, 1 functions can be made from A to B? I think this question was also there in the question paper. That's why I'm telling. Okay, what is the number of 1, 1 functions from A to B? So the answer is Just you note down this formula, that's all, okay? Number of one functions from A to B is equal to NPM. NPM, where N is greater than or equal to M. The value of N must be always greater than or equal to M. In the other case, if N is less than M, then 0. Clear? Just note it down. That's all. And for number of onto functions, also some formula is there, but that is a very complicated formula that is not in our level. Okay, that is beyond our level, beyond our course of study actually. Okay, so that kind of questions will not be asking. Okay, so don't worry. But in some particular case, some question can be asked onto functions also. For example, suppose a set A has 3 elements and set B has 2 elements. This kind of a question can be asked. Set A contains 3 elements, set B contains 2 elements. How many onto functions can be made from A to B? How many onto functions can be formed from A to B? Yeah, I have a question, same question. Okay. These questions are from NCERT exemplar problems actually. Okay. A is equal to 1, 2, 3 up to n. A set A contains n elements and set B contains 2 elements. Then the number of surjections from A into B. Number of surjections means number of onto functions. It's the generalized question actually, this one. So what I have taken is A contains 3 elements and B contains 2 elements. So number of onto functions equal to. I think you may be knowing the answer also. The number of functions, total number of functions will be what? This set contains 2 elements and this set contains 3 elements. So number of functions will be 2 cube, n raised to m. Number of functions will be, total number of functions will be 2 cube, 2 n raised to m, 2 cube. Okay. And out of these 2 cube, 8 functions, 2 functions won't be onto. Okay. 2 functions will not be onto. Okay. One will be like this. All elements can be mapped to the first element. Okay. One free element we need. Onto means every element must have a pre-image. Okay, sorry. Onto means every element must have a pre-image. Okay. Okay, some comment may be there. Let me see. So can you please explain some basics of one and onto functions? Okay. I will see. Okay. Yeah. So 2 functions will not be onto. One is this one. All elements mapped to the first element. And similarly, all elements can be mapped to the second element. That is another one. Except all others will be onto. That means we have to subtract 2. Clear? Total number of functions will be 2 cube. Okay, 2 raised to 3. And out of which only 2 functions will not be onto. One will be like this, and other will be mapping to the second element. So same idea, we can generalize. Okay. So this question, A contains n elements. Okay. Set A contains n elements. And set B contains 2 elements. Set B contains 2 elements. So the question is number of surjections from A to B. Number of surjections from A to B. So same idea, what just I have explained. Total number of functions will be what? Set B contains 2 elements and set A contains n elements. So total number of functions will be equal to 2 raised to n. Total number of functions equal to 2 raised to n. And out of that, 2 particular functions will not be onto. Okay. All elements will be mapped to one element. Okay. All can be mapped to the first element. That is one case. Then second case, all elements can be mapped to the second element. Like this. So if you remove that 2, that will be the answer. So 2 raised to n minus 2. Okay, this is a problem from the NCERT exemplar book. Similar problem was asked in the term 1 examination also. No? Yeah. Okay. Let us take another question. F is a function from the closed interval -4, 4 to the closed interval 0 to 4 given by f of x equal to root of 16 minus x square. Root of 16 minus x square. Show that f is an onto function but not a 1-1 function. F is an onto function but it is not a 1-1 function. So the function is f of x equal to root of 16 minus x square. Okay. Okay. So is it 1-1? Yeah, why it is not 1-1? That's my question. Anybody want to say any comment? Any response? Please type in your chat box, okay? Why it is not 1-1? If it is not 1-1, why it is not 1-1? Any answer? Okay, no comments. Okay, let us find the image of -4. Okay, what is the image of -4? F of -4. So f of -4 means you will get very clearly it is 16 minus 16 only, that is equal to 0. Root of 16 minus 16, that's equal to 0, isn't it? Now what is f of 4? F of 4. F of 4 is also 16 minus 4 square. 16 root of 16 minus 16, and that is again equal to 0. That indicates what? -4 and +4 both are having the same image. No? Means two different elements are having the same image. That means it is not a 1-1 function. Okay. To disprove it is 1-1, but not 1-1, you can give any example. Okay, a counter example is enough. You can put some other value also. Okay. -2, +2, like that. -1, +1. Everywhere you will get the same image, same output. So it is not 1, 1. Okay. F of -4 and f of 4 both are same. That means it is not 1, 1. Now we have to prove that it is an onto function. Okay. It is an onto function. So how to prove that? The function is f of x equal to root of 16 minus x square. Okay. The domain is -4 to +4 to the range is 0 to 4. So we have to prove that it is an onto function. The domain is -4 to +4 and range is 0 to 4. Then we have to prove that it is an onto functions. How it can be. So only we have to show that the range is equal to 0 to 4. Okay, the range is equal to 0 to 4. So x belongs to -4 to +4. So we prove that the range is exactly 0 to 4. Otherwise, you take any element in this interval 0 to 4, then show that there exists a pre-image in the domain. Okay. Okay. So let some y belongs to the interval 0 to 4. Then we have to prove that for this y, there exists a pre-image in the interval -4 to +4. So which implies y must be equal to root of 16 minus x square. Y must be equal to root of 16 minus x square, and which implies y square is equal to 16 minus x square. Okay. So which implies that x square equal to 16 minus y square. Yeah, x is equal to root of 16 minus y square. So if there is a pre-image, then that must be of the form root of 16 minus y square. Clear? We have chosen some y, and if there is a pre-image, some x, then that x must be of the form root of 16 minus y square. Okay, now we have to check only the 16 minus y square. Root of 16 minus y square must always lies in the interval -4 to +4. Okay, so how to check it? For that, it is given that y belongs to 0 to 4. Okay, y belongs to 0 to 4. So what about y square? Y square belongs to 0 to 16. If the values y is in between 0 and 4, so y square is in between 0 and 16, isn't it? That means 16 minus y square. 16 minus y square also belongs to 0 to 16. Okay. So that means root of 16 minus y square belongs to which interval? -4 to +4. 16 minus y square is in between 0 and 16. So root of 16 minus y square will be in between -4 and +4. So very clearly, this value belongs to which interval? -4 to +4. So that means for every y, there exits the pre-image. The pre-image is equal to root of 16 minus y square. Okay. For every y, the pre-image will be root of 16 minus y square. Now there is a second part for this question actually. What is the value of a for which f of a is root 7? That is very simple. F of a is root 7 means very easily we can find out. F of a stands for root 7. Okay. So root of 7 is equal to 16 minus x square. Or 6 f of a. So in place of x, I have to put a. So 16 minus s square is equal to root of 16 minus s square is equal to root 7. So if you solve, you'll get the value of a. Okay. So 7 must be equal to 16 minus s square. So s square must be equal to 9. Okay. So a must be equal to plus or minus 3. Very easily we can find out. Okay, let us take another question. F is a function from R minus 4 by 3 to R, defined by f of x equal to 4x by 3x plus 4. Show that f is one function. Also check whether f is an onto function, onto or not. So function is from R minus 4 by 3 to R. R minus 4 by 3 means all real numbers except minus 4 by 3. Okay. So we have to prove that this function is 1. But we don't know anything about the onto. We have to check, okay, whether it is onto, like that the question says. So first 1, I think very easily we can prove it. Okay. For 1, let f of x1 equal to f of x2. That means 4x1 divided by 3x1 plus 4 is equal to 4x2 divided by 3x2 plus 4. The usual procedure. Then that is no problem. Okay, children, sorry for the interruption. Today there are some connectivity issues. Okay, in between some breakage, something is there. Sorry, okay. I don't know whether you have followed this question anyway. This is my question.
F is a function from R minus 4 by 3 to R, defined by f of x equal to 4x by 3x plus 4. The question is, show that it is a 1 function. 1 can be easily, you can also prove. Okay, already I have proved it. Whether you have seen or not, I don't know. There was some interruption. Okay, some video problem was there actually. Okay, anyway, we have proved it is 1. Usual method, f of x1 equal to f of x2. At last, that implies x1 equal to x2. Everybody can do by yourself also. Now the question is whether it is onto or not. Is it an onto function? That is the next part. Okay, for the time being, I assume that it is onto. In that we will proceed. Okay. If possible, okay. Suppose it is onto. Then what happens? Every element, okay, in the codomain choose some y belongs to the codomain. Okay. Y belongs to the codomain. And have a pre-image, some pre-image, okay. X in the domain. Domain is R minus 4 by 3. Suppose it is onto. If it is onto, then very clearly, therefore, what we can say that y must be equal to f of x. No? Y must be equal to f of x means what is the given definition apply usually? What is the given definition? 4x by 3x plus 4. 4x by 3x plus 4. 4x upon 3x plus 4. Okay. If there is a pre-image x, then y must be equal to 4x by 3x plus 4. We don't know whether it is onto actually. Okay. We are just checking. Suppose it is onto. Then there must be some x such that y must be equal to 4x by 3x plus 4. Let us find that x. Okay. If it is there, let us find that x. That means 3xy plus 4y is equal to 4x. Okay. Now our target is to find x. What is the expression for x actually? If some x is there, what is the value of x? So what we will get? You take the x terms together. Okay. So 4y is equal to 4x minus 3xy, isn't it? That is 4y equal to x into 4 minus 3y. X into 4 minus 3y. Okay. Okay. Our target is to find x. So that we have collected the x terms together. X terms in one side, then take x outside. This is the way. After that, you will get x. What is x? X equal to 4y upon 4 minus 3y. Clear? X equal to 4y by 4 minus 3y. Okay. Remember, if there is a pre-image x, then that x must be equal to 4y by 4 minus 3y. Now you tell me, this value always exits. Is it possible? Whether it is well defined in the domain, is it always exists in the domain? That's the question. So how we can check that one? You just you see the expression. The denominator is what? 4 minus 3y. So denominator is 4 minus 3y means very clearly the denominator cannot be 0 now. Denominator cannot be 0. That means 4 not equal to 3y. Okay. In order to make it well defined, y 4 may not equal to 3y. 4 cannot be equal to 3y. So that means what? Okay. for x is to be well defined, what we can say? Four cannot be equal to 3y. No. That means y cannot be equal to 4 by 3. Okay. Y cannot be equal to 4 by 3. That means what? If there is a 4 by 3, 4 by 3 is there in the real numbers. No, 4 by 3 is a real number. So that 4 by 3 has no pre-image. When y is 4 by 3, this x will not be defined. No, x is something divided by 0 will come. No, so that is not defined. That means y cannot be 4 by 3 means what's the meaning? 4 by 3 has no pre-image. Okay. From where we have taken this y? Y we have taken from the domain, sorry, codomain R. So, but y cannot be 4 by 3. Y cannot be 4 by 3. So that means 4 by 3 has no pre-image. Okay. 4 by 3 has no pre-image means it is not a onto. That's all. Okay. Okay, children. Now I am going to the inverse trigonometric functions. Okay. With these examples, I will move on to the inverse trigonometric functions. Just wait a minute. Okay, let me open the folder. Okay. Inverse trigonometry functions. So all of you know that all the trigonometry functions, okay, sin x, cos x, tan x, etc. So this sin x is a function from all the real numbers, isn't it? Domain is all real numbers, and the range is -1 to +1. Domain is all real numbers, and range is -1 to +1. You know the graph of sin x also. So I will show you the graph of sin x, okay? Just wait a minute. Let me open. Okay. I think the screen is visible to all of you. On the screen, you can see the graph of sin x. Okay. So sin x is a function from all real numbers to the closed interval -1 to +1. Okay. Is it a 1-1 function? Is it a 1-1 function? No, very clearly, it is not a 1-1 function. Okay. Because we know sin 0 is 0, sin pi is 0, sin 2 pi is 0, etc. No? So many elements are having the same image. So it is not a 1-1. Okay. But if you take the range -1 to +1, it is on to. In between -1 and +1, every element is having a pre-image. Okay. In between -1 and +1, every real number is having a pre-image. So it is an on-to function, but it is not a 1-1 function. For a function, in order to exit its inverse, it must be both 1-1 and on-to. Okay. It must be 1-1 and on-to. Actually, the inverse concept, inverse of a function is not in the syllabus. That's why some problem may be there for you. Okay. So let me tell you. Suppose we have a function, the mapping I am giving like this. Okay. Now it is from the arrow diagram, what you can see that it is not 1-1. It is not 1-1. But it is on to. It is on to, but not 1-1. Now, can you think about the inverse function, the reverse function from B to A? If the sets are A and B, so can you think about the function which is mapping or mapped from B to A? Not possible, because if I take the reverse function, you can see the third element here is having two images. So 1-1ness, 1-1 property must be there to define the inverse of a function. Okay, the inverse of a function. 1-1 property is a must. But it is on to. Okay, here it is on to. Now on to is also a must. Now let me take another arrow diagram, another function like this. Okay, it is 1-1. It is very clearly 1-1, isn't it? In A, different elements in A are having different images in B. So it is 1-1, but it is not onto. It is not onto because you can see a free element in the second set. One free element is free there. So when you take the reverse mapping from B to A, what happens? There is an element which is not having a image in A actually. Okay, that means the function property will fail actually. So that means to get the inverse of a function, to define the inverse of a function, both 1-1 property and on-to property must be there. So please understand it, okay? Then only we can think about the reverse of a function, yeah, inverse of a function, okay? Let me draw another arrow diagram that is both 1-1 and on-to. Now let us look at this arrow diagram. This function is both 1-1 and on-to. This function is both 1-1 and on-to. For example, I take this element as 1, 2, 3. Let me mark it as A, B, C, any elements. Okay. F is a function from A to B. Generally, we say F is a function from A to B. So here, it is both 1-1 and on-to. So F of 1 is A, F of 2 is B, and F of 3 is equal to C. Okay. Now, can you think about the reverse function? The function from B to A, the reverse mapping. Okay. Yeah. So that we can write the F inverse. So F inverse is a function from B to A given by F inverse of A is equal to 1. So, and F inverse of B is equal to 2. And F inverse of C is equal to 3. So this is this reverse mapping is called the inverse of the function. Okay. Generally, the inverse of a function we denote by this symbol, F inverse. So this concept you must have. Then only we can go for the inverse trigonometric functions. Okay. So function must be 1-1 and on-to. Then only the inverse exits. Okay. Clearly, function must be 1-1 and on-to. Then only we can define the inverse of that function. Clear? Okay. Now we are going to find the inverse of the trigonometry function. Okay. The sine function. Very clearly, I already told you this is not a 1-1 function, because you can see f of 0 is 0, f of pi is 0, f of 2 pi is 0. No, like that. Yeah, f of 3 pi by 2 is -1, f of minus pi by 2 is -1, like that. So how can we make it a 1-1 function? Sorry, how to define the inverse of that function? If I take the whole domain, whole real numbers, the whole domain, it is not 1-1 and it is not 1-1. It is on to, but it is not a 1-1. So to make it 1-1, we will restrict this function to a certain interval. Okay, to a certain limited interval. But remember, the range is -1 plus 1 only. That should be maintained. Okay, the value of the sine function always varies from -1 to +1. So that value should be there, and we have to choose such an interval. In that interval, we should get all the values of sin x. That is from -1 to +1. Clear? So what we have to cut this domain into some special interval. So how to do it? Just a minute, okay? Now you see what I have done. This sin x function, I have restricted this function to a particular interval, that is minus pi by 2 to plus pi by 2. Okay. The other portions I have removed. Sine function only, but except the minus pi by 2 to plus pi by 2, the remaining portions I have removed. So what you will get only this much. Okay. Now in this interval, you look at this function in this interval minus pi by 2 to plus pi by 2. So very clearly, you can observe that it is both 1-1 and also on2. Okay. Minus pi by 2 to plus pi by 2 domain, and the range will be -1 to +1. So then we can think about the inverse of the function. So naturally, the inverse of the function will be from -1 plus 1 to minus pi by 2 to plus pi by 2. Okay, one more thing. In place of minus pi by 2 to plus pi by 2, you can choose any other interval also apart from this interval. Okay, you can choose pi by 2 to 3 pi by 2. In that interval also, it will be 1-1 and on2. Okay, otherwise we can choose 3 pi by 2 to 5 pi by 2. In that interval also, it will be again 1-1 and on2. Otherwise, we can take minus 3 pi by 2 to minus 3 pi by 2 to minus pi by 2. In that interval also, it will be again 1-1 and on2. Okay, but we choose this interval that is very close to the origin, actually 0. And this interval minus pi by 2 to plus pi by 2 has a special name, and that is known as the principal value branch of the sine inverse function. Okay. The interval from minus pi by 2 to plus pi by 2. That is called the principal value branch of the sine inverse function. So sine inverse function is a function from minus 1 plus 1. Okay. Minus 1 plus 1 to minus pi by 2 to plus pi. This is the graph of the sine function. Okay. This is not the inverse function actually. The inverse function will be reversed actually. Domain and range will be interchanged. Let me show you the graph of the exact graph of the inverse trigonometry function. Okay. Okay. Now you can see the exact graph of the sine inverse function. So the domain is minus 1 to plus 1. Minus 1 and plus 1 you cannot see in this graph actually. D represent minus 1 and this point C represent plus 1. So minus 1 plus 1 and the range is minus pi by 2 to plus pi by 2. Okay, minus pi by 2 to plus pi by 2. H stands for the value minus pi by 2 and G stands for the value plus pi by 2. So clear? Now in this interval, this function is 1, 1 and on 2. Clear? Yeah. So in this way, we are defining the inverse of sine function actually, okay, by restricting its domain. So this interval minus pi by 2 to plus pi by 2 is known as the principal value branch of the sine function. So what we can say, sine inverse x, we write the inverse function like this. Okay, all of you may be knowing this notation, etc., everything. So sine inverse x is a function from minus 1 plus 1. The domain is minus 1 plus 1. And what is the range? Minus pi by 2 to plus pi by 2. And minus pi by 2 to plus pi by 2 is known as the principal value branch. Principal value branch. So what is the value of sine inverse minus 1? So sine inverse minus 1 will be minus pi by 2. Okay. And what is the value of sine inverse 1? Sine inverse 1 is equal to pi by 2 because sine pi by 2 is 1. And what is the value of sine inverse 1 by 2? Sine inverse 1 by 2 means we have to think when sine x equal 1 by 2. Okay. When sine x equal 1 by 2, we know sine 30, yeah, sine pi by 6. No? So sine inverse 1 by 2 is equal to pi by 6. So these are some special, yeah, particular values actually. What is the sine inverse of minus 1 by 2? Sine inverse minus 1 by 2. And that's equal to minus pi by 6. Minus pi by 6. So whatever the values, sine inverse, always the value must lies in its principal value branch. The principal value branch is minus pi by 2 to plus pi by 2. So you have to remember that particular interval. Okay, for every inverse trigonometry function, there is a principal value branch. For cos inverse x, this may not be the principal value branch. Okay, that we will see. So that's about the sine inverse function. Okay, now similarly, we will go for the cos inverse function. Cos inverse function is also in the similar way. So this is the graph of the cos inverse function. The everything is same. Procedure is everything is same only. We know cos x is also not a 1-1 function. Cos x is not a 1-1 function. So what we do? we restrict the domain to certain interval to make it 1, 1 and on 2. Okay. But here the interval is different, not to minus pi by 2 to plus pi by 2, because we have to get the value of cos x, all values of cos x. That means from minus 1 to plus 1, minus 1 to plus 1. Minimum value is minus 1, maximum value is plus 1. No? So we should get all the values of cos x such that we have to restrict the interval. So what is the interval here? That is 0 to pi. The same procedure. I am not going to explain all those things. You know the graph of cos x. No? This is the graph of cos x actually. You see. Okay. So it is not 1, 1. So we restrict the cos x into a particular interval. Then after that, we will get the inverse of the cos x. Anyway, you just remember the graph. Okay. Sometimes the graph also may be asked in the exam to draw. Last year also, I think, some question paper, it was there. So the principal value branch of cos inverse x is actually 0 to pi. The principal value branch I am telling. Okay. But we can choose any other branch, any other interval also to make it 1, 1 and on 2. Okay. You can choose an interval from pi to 2 pi also. Okay. In pi to 2 pi also, if you choose the interval, then also it will be 1, 1 and on 2. Otherwise, you can choose minus pi to 0. In minus pi to 0 also, if you choose only that interval, again the function will be 1, 1 and on 2. Okay. But these are not the principal value branches. Principal value branch means that is fixed, that is defined by us, and that is the interval from 0 to pi. So in that interval, only we have to see the graph of the cos inverse function. Okay. So domain is minus 1 to plus 1. Okay. Cos inverse x is a function from minus 1 to plus 1. And the range is 0 to pi. 0 to pi is known as the principal value branch of cos inverse x. Okay. So please remember the principal value branch of cos inverse x. So what is the conclusion? Cos inverse x. Cos inverse x is a function from minus 1 to plus 1, minus 1 to plus 1 to the interval, closed interval 0 to pi. So 0 to pi is called the principal value branch of cos inverse. Okay. So in particular, some values. For example, what is the value of cos inverse minus 1? Cos inverse minus 1. When cos is minus 1, everybody knows that is pi. So cos pi is minus 1. So cos inverse minus 1 is pi. What is cos inverse of 1? Cos inverse of 1 means that is 0 because cos 0 is 1. Okay. What is cos inverse of 1 by 2? What is cos inverse of 1 by 2? For what value? Cos x becomes 1 by 2. Cos 60, pi by 3, no? Pi by 3, like that. So whatever we find the value of cos inverse x, that must always lies in the principal value branch. Okay. We cannot take any value outside from this principal value branch. Remember. Because cos inverse, not only cos 0 is 1. Cos 0 is 1, okay. Okay. But cos 2 pi is also 1 actually. You know, no? Cos of 2 pi is also 1. But can you write cos inverse 1 is equal to 2 pi? Cos 2 pi is 1. So can you write cos inverse 1 is 2 pi? No, that is wrong because 2 pi is not in the principal value branch of the cos inverse function. So we have to choose only a value which belongs to that principal value branch. Okay. Okay, let me ask another question. What is the value of cos inverse of minus 1 by 2 then? Cos inverse of minus 1 by 2. So that means we have to find a value which belongs to the principal value of cos inverse x, satisfying some cos inverse or cos x equal to minus 1 by 2. Cos x equal to minus 1 by 2. So we have to find some x such that cos x equal to minus 1 by 2. And that x must belongs to the principal value branch of cos inverse. That is 0 to closed interval 0 to 2 pi. Sorry, 0 to pi in that interval. So how to get it? Suppose this is some y. Let it be y. Okay. So which implies cos y. Cos y must be equal to minus 1 by 2. So we find some value satisfying cos y is minus 1 by 2. So how to get it? Cos y must be minus 1 by 2. Okay. So we have to get a value from the interval 0 to pi. That means first and second quadrant in that area. Okay. And we know that the first quadrant means cos is positive only. We will not get negative. Then definitely the value must be in second quadrant. No. Cos x is negative means it must be in the second quadrant only. So we have to find a value. We have to search a value in the second quadrant. In that way, you have to think. Okay, it's very simple actually. We know cos of pi minus theta. Yeah, pi minus x equal to minus cos theta. The trigonometric formula. You know, cos pi minus theta is minus cos theta. Second quadrant, cos minus. So put suitable value for theta. So we put a theta is equal to pi by 3. Cos pi minus pi by 3 must be equal to minus cos pi by 3. If I put theta is pi by 3, so cos pi minus pi by 3 must be equal to minus cos pi by 3, and that is minus 1 by 2. So that means what is the value of y satisfying cos theta is minus 1 by 2? That is pi minus pi by 3. Pi minus pi by 3 is what? 2 pi by 3. You know? Directly also you may be knowing. Anyway, this is the way. So cos 2 pi by 3 is minus 1 by 2. And very clearly 2 pi by 3 also belongs to the principal value branch. Okay, that also we have to ensure. 2 pi by 3 belongs to the principal value branch of cos inverse x. Clear? So we have to choose, we have to find a value that lies in that particular interval. Similarly, what is the value of cos inverse minus root 3 by 2? Actually, in inverse trigonometric functions, many properties are deleted actually. Okay, only very, very basic things are only there. And some more properties are there earlier and that were deleted. Okay. And if you know some more properties and if you apply that property, this can be done in that way also. Okay. But sometimes we may use that property for numerical problems sometimes. Okay. For example, we have a property actually. Cos inverse minus x is same as pi minus cos inverse x. There is nothing wrong if you use this property in doing the numerical problems like this. For example, multiple choice question, etc. No? Cos inverse of minus x is same as pi minus cos inverse x. That's all. So cos inverse of minus root 3 by 2, you can write it as pi minus cos inverse root 3 by 2. Even though this property is not given in the syllabus, in the new syllabus, earlier it was there. Okay. There is nothing wrong if you apply also. So that is equal to pi minus cos inverse root 3 by 2, that we know cos 30 degree. Cos 30 is root 3 by 2. Pi minus pi by 6, that is 5 pi by 6. Clear? And also you know that 5 pi by 6 belongs to the principal value branch. 5 pi by 6 means in degree you think, so you can identify. 5 pi by 6 stands for 150 degree, isn't it? Isn't it? 150 degree. So 150 degree means in between 0 and 180. Okay. So again, actually the formula is same what we have applied here, okay? The same thing though. You see, cos pi minus theta is minus cos theta. Basically, this is the principle behind that property also. Cos pi minus theta is minus cos theta, okay? If you are not applying that property, you can apply in the same way as earlier what we have done. What we have done? Cos pi minus theta is minus cos theta. If you are not applying this property, you can do as earlier. So cos pi minus pi by 6. Cos pi minus pi by 6 equal to minus cos pi by 6. And minus cos pi by 6 stands for minus root 3 by 2. Minus cos root 3, sorry. Minus cos 30 degree. So pi minus pi by 6 means this is 5 pi by 6. So cos 5 pi by 6 equal to minus root 3 by 2. That means 5 pi by 6 is the value of cos inverse minus root 3 by 2, isn't it? The same principle actually. Only the basic trigonometry is required for this. So that's about a sine inverse and a cos inverse. So the next one is tan inverse x. Tan inverse x. Just wait a minute. Just I will show the graph of the tan inverse x function, okay? This is the graph of the tan inverse x function, okay? Tan x graph you see. This blue graph represents the graph of tan x. So what is the domain of tan x actually? Domain of tan x means all real numbers except odd multiples of pi by 2. Tan pi by 2 is not defined. Tan 3 pi by 2 is not defined. Tan minus pi by 2 not defined. So tan is not defined for all odd multiples of pi by 2, isn't it? So you can see in pi by 2, what happens? The graph, if you approach us from the left side of pi by 2, it is going to some infinity, and the other side, if you just move pi by 2, right side of pi by 2, the right side graph is going to some negative infinity. So at pi by 2, some problem is there actually. At 3 pi by 2, some problem is there. At 5 pi by 2, some problem is there. No? Means not defined actually. So except those points, everywhere this tan x is well defined. Tan x is well defined. Okay. So that's the domain of tan x. All real numbers except odd multiples of pi by 2. Okay. So very clearly it is not 1 if you take the whole real numbers as the domain. No? So what we do? We restrict it. We restrict it to only minus pi by 2 to plus pi by 2. We take only one branch, this one. The graph that is just passing through the origin. And all the remaining portion we will remove actually. Okay, that means we are restricting the domain into the open interval minus pi by 2 to plus pi by 2. Open interval minus pi by 2 to plus pi by 2, because at pi by 2 and minus pi by 2 it is not defined. So we cannot take that points, okay? So in that interval, very clearly it is 1, 1 and on 2, okay? In this interval, minus pi by 2 to plus pi by 2, this function is very well defined, means 1, 1 and on 2. Just I have drawn two lines at minus pi by 2 and plus pi by 2. In between this minus pi by 2 and plus pi by 2, the tan function is 1, 1 and on 2. This is the graph of tan x. Okay, not the inverse actually. To get the inverse, just we interchange x-axis and y-axis. That's the process, okay? F is a function from A to B means F inverse is a function from B to A. So tan inverse x is a function from all real numbers to minus pi by 2 to plus pi by 2. Okay, all real numbers to the minus pi by 2 to plus pi by 2. So that red colored graph represent the inverse of tan x actually. Okay. So if I restrict the tan x only to this particular interval, this is the graph actually. Now you can see only that one particular graph. No? That is the graph of tan x in minus pi by 2 to plus pi by 2. When you take the inverse means we have to just reflection Actually, it is a reflection of the tan x graph with respect to the line y equal to x. Okay, just interchanging x and y means you just take the reflection of that graph. In that way, also we can say about the inverse. Okay. So concentrate only on this tan inverse x graph. Okay, this is the graph of tan inverse x. Please understand. Okay, so the domain is all real numbers very clearly. Inverse of tan x I am telling. Okay, tan inverse x. The domain is all real numbers and the principal value branch, the range, yeah, principal value branch is minus pi by 2 to plus pi by 2. The open interval minus pi by 2 to plus pi by 2. So tan inverse x is a function from all real numbers to the open interval minus pi by 2 to plus pi by 2. Okay, why we have taken only that particular interval, you know, to make it 1, 1. Okay, to make it 1, 1 as in the earlier case. So that is the principal value branch of tan inverse x, minus pi by 2 to plus pi by 2. Open interval. Minus pi by 2 is not in that interval. Plus pi by 2 is also not in that interval. Remember, you know. Okay. Now, let me take some particular numerical values. So what will the value of tan inverse 1, for example? Very simple value. So tan inverse 1 must be pi by 4 because tan pi by 4 is 1, you know. Tan inverse 1 is pi by 4. So what is tan inverse of 1 by root 3? 1 by root 3. Tan inverse of 1 by root 3. Everybody knows, okay? When tan is 1 by root 3, tan 30 degree. 30 degree means pi by 6, isn't it? Pi by 6. And remember, all these values are in this interval, minus pi by 2 to plus pi by 2. Clear? And what is tan inverse of minus 1 by root 3? Minus 1 by root 3. So we have to find a value such that tan x is minus 1 by root 3. So what is that? Minus pi by 6 only. Directly we can put minus. Tan minus theta is minus tan theta. That's why. Okay. So in this way, so all these values must be lying in the principal value branch of tan inverse. Clear? Similarly, we can go for cot inverse x, sec inverse x, and cosec inverse x. Now you can see this is the graph of sec x actually. Okay. The graph of sec x. You are familiar actually. So this is the graph of sec x. Isn't it? So what is the domain? The domain is, from the graph you can observe, no? The domain is all real numbers except the odd multiples of pi by 2. Odd multiples of pi by 2. At pi by 2, you can see some problem is there, just like tan. Okay, some break is there. 3 pi by 2, you can see some gap is there, etc. etc. All odd multiples of pi by 2, the function has no value actually. Okay, means the domain is all real numbers except the odd multiples of pi by 2. What about range? Very clearly from the graph also you can see the graph always in the positive side, the graph always lies above 1. No? The value never comes less than 1 in the positive side actually. And in the negative side, if you see, the graph is coming up to -1 only, -1 only, below -1 only. Okay, so the graph never comes in between -1 and +1. So there is no value for the sec x in between -1 and +1. It lies outside, okay, that in area, -1 to +1, including -1 and +1 that are there. But in between, no value can be taken. Very clear, okay? So it is not 1, 1 very clearly. So to make it 1, 1, what we do? We will take only some particular interval, okay? Some special interval we'll choose, okay? So this is the interval. All the remaining portions I have deleted. To make it 1, 1, so to make it 1, 1 function, all the remaining portions I have deleted. So I have taken only which interval, you see? Which interval I have taken? 0 to pi. Okay. The interval what I have taken is 0 to pi. Okay. And in between 0 and pi, you can find a gap again. Pi by 2 is not there. Pi by 2 cannot be. Okay. Except pi by 2. That's the meaning. Except pi by 2. So if you take this interval, the sec function is also 1, 1 and on 2. So which interval we have taken? The closed interval 0 to pi except pi by 2. Except pi by 2. So this is the graph of sec x in that particular interval. So sec inverse means it will be reversed. Okay, it will be reversed. X and y will be interchanged. Now I will show you the exact graph of sec inverse x. So this is the graph of the sec inverse x. Okay. So what is the domain actually? Domain of this sec inverse x? All real numbers except these values from -1 to +1. Okay. Open interval -1 to +1 is not there. And the principal value branch is 0 to pi, 0 to pi, except the point pi by 2. So sec inverse x is a function from r minus -1 to +1, open interval -1 to +1, to which interval? Closed interval 0 to pi and except pi by 2. Okay, except the point pi by 2. So this is the principal value branch of the sec inverse x. All the points, real numbers from 0 to pi except pi by 2, except pi by 2. So that is the principal value branch of sec inverse x. Okay, like that, then cosec inverse x. Cosec inverse x is a function from, I'm just directly telling, r minus -1 + 1 to the interval minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2, except 0. Okay, except 0. The same argument is applying here also. So what is the principal value branch of cosec inverse x? Means minus pi by 2 to plus pi by 2, except the point 0. Okay. Similarly, cot inverse x. Cot inverse x is a function from R to open interval 0 to pi. So that's about the domain and range of the inverse trigonometric functions. So we have to remember the principal value branch, and some basic properties are the very fundamental property. That's all. All the other properties are deleted actually. Some basic properties. Sine inverse of sin x equal x. Okay. True for all the other functions also. Sine inverse of sin x equal x, where x belongs to Which interval? X belongs to minus pi by 2 to plus pi by 2. Wherever it is defined, this sin x, okay? Similarly, in the reverse way, what is sine of sine inverse x? Sine of sine inverse x is also equal to x. Sine of sine inverse x is also equal to x. Where x belongs to minus 1 to plus 1. We are sine inverse x is coming first, okay? Sine inverse x is defined in minus 1 to plus 1. So this property, this is the only property is in the syllabus. All the remaining portions are deleted actually, okay? Applied for all functions, cos inverse cos x, tan inverse tan x, etc., the same thing. Okay. And from this chapter, I think 2 or 3 marks question only may be asking. Okay. Some fundamental basic problems only coming. If you see the previous year question paper, only very, very simple problems are asked actually, based on the principal, value, branch, domain, range, etc. Okay. Some problems we will do in the evening session. Okay. Some problems from this chapter actually. So I think the time is 4 o'clock. I have taken all this little faster. Okay. I don't know how many of you have followed actually, because of the time constraint. That's why. In between, some problem also came, some technical problem, etc. So we have lost some time also. Okay. So we'll stop here and we will meet again in the evening session. Okay, 6:30. We will do some problems from this chapter. And after that, if time is there, we'll do some more problems from other area also. Okay. Thank you.